Hello, I'm Craig McAtee, the CEO and Executive Director of the National Coalition of Advanced Technology Centers, and we're presenting on the future of technician in the workforce, demystifying Industry 4.0 for the Manufacturing Career Summit from the NTMA Foundation and AMPed. Looking forward to getting through our presentation so that you can learn a little bit about what we've learned and what we're doing in the field. So let's start. The agenda is basically a brief overview of NCATC and what we cover across the nation, what we've been doing in Industry 4.0, what we've discovered, what education is doing and can do more of, and same with industry, and a couple of examples of best practices, as well as touching on a couple of really important industry recognized credentials that are evolving in Industry 4.0. So our focus areas at NCATC are these four major pillars, if you will. The future of work, which is what we're talking about today, Industry 4.0. Some people call it smart manufacturing. A lot of folks are calling it smart automation, but it's all the same. Cyber physical world connected, and we'll get into what that means in a minute. Obviously, we focus a lot on applied learning, work-based learning, and training that goes on in apprenticeships, internships, co-ops, and even entrepreneurship in the nation, and a very important part of the puzzle for the 21st century learning and work together, especially when it's coupled with learning in competency-based applied knowledge and skills, where the industry recognized credentials are in part of that model going forward. And last but certainly not least is the diversity, access, equity, and inclusion of underserved populations, and those folks that are underrepresented, whether it's females in engineering or manufacturing jobs, or urban areas, Black and Latino folks that really need more access to training and jobs. That's what we're after in our mission and our approach to training across the nation. So let's get into what makes up NCATC's membership across the nation. We have over 165 community and technical colleges in 41 states, from Hawaii to Maine to Florida. Those are represented on this map briefly. And then there's 42 and growing strategic corporate partners that are also members of our network. And those folks are, of course, NTMA has been a part of our organization for quite some time. And you see this list of logos that everybody from Amatrol and Association for Manufacturing Technology, all the way through MSSC, Sandvik, Lincoln Electric, Miller Electric for welding, Haas, Tooling USME. The list is just huge of people that are really in the field doing great things with hands-on experiential learning, or complementing those fields in everything we're doing across the nation, including Industry 4.0. We also work very closely with the 8 of the 14, now 17 actually, manufacturing innovation institutes across the nation. Those with the red triangles above them are the ones that we are part of, and in the workforce and economic education groups. Everybody from America Makes in Youngstown, Ohio for additive manufacturing, to lightweight materials in Detroit, and digital machining from MXD over in Chicagoland, all the way out to the West Coast with NextFlex, flexible electronics, smart manufacturing, et cetera, and down to the robotics group in PA, et cetera. So those are the ones that we work with very closely, and they're part of the equation when it comes to Industry 4.0, as you can imagine. Let's look deeply into what the fourth industrial revolution is all about. Obviously, we've come a long way in the last century, as you see represented on the bottom. Industry 1.0, mechanized or mechanical production. Henry Ford with the Model T cars was a really good example of that. And moving into, as he moved that into mass production, that became much more Industry 2.0, if you will, looking back and labeling it that way to represent where we are at 4.0. And then the last 30 or 40 years, electric automation, introducing some robotics and, automated welding, et cetera, with aerospace, automotive, et cetera, appliances. That was the Industry 3.0. When we got into computer numerical machines, CNCs, moving from the physical manual lathes and mills, milling machines, et cetera. And then we've now connected everything in the smart factory, and that we'll be talking a lot about that in Industry 4.0. So how many of you watching this presentation have any of these devices, whether it's an Apple Watch or a Nest Ring doorbell or a thermostat that's pictured in the upper right hand that's connected to the internet? Obviously, some of you on this have Google Home or Alexa devices as well, where you can just say, hey, Alexa, what's the weather like outside? And she'll talk to you and tell you exactly what's going on outside or inside. Those are really the reason I ask you about this. Is these are cyber physical connections in your house or on your wrist that's really connected to the Internet of Things. And we'll talk a little bit about that in a minute here. But it's nothing different in industry. So over the last couple of years, we've worked with 9 community colleges as a pilot with industry involved. They're listed on the state or on the screen here. And we've decided that we wanted to see where their gaps were in their curriculum and their training, and coupled that with industry knowledge across the nation. And so we basically developed a glossary of terms, which is a pretty nice foundation for knowing what Industry 4.0 is made up of. And those terms are here on your screen right now. The industrial Internet of Things is just an industrial version of those things I showed you connected to the Internet of Things, your Apple Watch, your phone, your refrigerator, or your thermostat, et cetera. But in the factory that makes and produces things, and that's where NTMA comes in, is the production of equipment and or components that go into those equipment. So all those things have a place connected to the internet. Additive manufacturing, which is 3D printing, autonomous robotics, which we'll get into a little more, the data analytics that comes from all these devices connected, and the data science that goes into analyzing that data is a very important part of that. Cloud computing is what connects all these devices to the Internet of Things. And then systems integration, those systems that run businesses that get connected to the shop floor are part of this. There's a lot going on in simulation where you can actually have a digital twin, as we call it, and take that as more of a video game version, if you will, of what's going on in the factory, and actually play out scenarios and simulate what may happen before it actually happens. So you can put in faults and safety items that will make sure that things run properly. And of course, that's all coupled with artificial intelligence. Every day, artificial intelligence gets smarter and more ubiquitous across the nation and the globe. And we'll talk a little bit about that. And then, of course, augmented reality and virtual reality and even extended reality are part of this equation. But everything around that we're doing has to be secure. And cybersecurity, if any of you are out there thinking about getting into computer-oriented roles that will help manufacturing, cybersecurity is one that goes everywhere. We need more and more experts to help us be secure in the data that we share across the internet. So definitions, real quick. Industry 4.0, primary driven over the last decade or so by a rise in the volume of data that's readily available out there on the internet. And computers and computational power and connectivity that's evolved over the last decade or more has continually made that more possible to use as well. And of course, then the emergence of the analytics and the data science that I talked about earlier and the business intelligence capabilities is really a big part of how the human machine interactions work, such as augmented reality, et cetera. And of course, improvements in the transferring digital instructions in the physical world have really come a long way as well. So those are the 4 major reasons that we're in this new revelation or revolution of Industry 4.0. Some of the foundational pieces of this over the last 2 or 3 decades has evolved into connecting 5 major parts of manufacturing: mechanical systems, electrical systems, hydraulics systems, as well as pneumatic systems, and that all coupled with programmable logic controllers, the brains that actually connect those systems together. And that's called Mechatronics in many parts of the world, including the United States. And that is a synthesis of those 5 disciplines, as you see on this. And it's across not just manufacturing, but in transportation, aerospace, even hospital systems, etc. Use this Mechatronics approach. If you have that foundation and knowledge about those 5 systems, you can very easily springboard into the next level, and that is Industry 4.0 with industrial Internet of Things. And that's the concept of connecting devices with on-off switches, pretty simple, to the internet. And it includes everyday items like I talked about earlier, whether it's your cell phone or your coffee maker, your lamps, all the way through machines and jet engines on an airplane and the drilling of an oil rig in the field. It's really a subset of industrial Internet of Things of the Industry 4.0. And so there's intelligent manufacturing and smart industry assets that are connected really do make that all occur and part of the big picture, the ecosystem of Industry 4.0. All right. Additive manufacturing, a lot of you have maybe even a 3D printer at your home as a hobby, but these have evolved over the last 4 decades to be extremely worthwhile. And they get their name, additive manufacturing, from the opposite of how we've manufactured over the last couple centuries or more, in that you subtract material from bar stock or forgings or whatever else is out there in the last revolutions of manufacturing and make a product from that. In additive, the term is correct. You start with nothing and you add material to that nothingness, that plate that's sitting there waiting for the 3D printer to add material to it. Therefore, it gets its name, additive manufacturing. And then, of course, it adds layer upon layer of material, whether it's plastic, metal, concrete, or human tissue. Yes, they are experimenting with printing ears and noses and even human organs, in a very futuristic look at what can be done with 3D printing. Again, 3D printing, additive manufacturing, they are synonymous. All right. Cloud computing, it's basically the storage of all this data over the internet and allows for easily sharing that information across multiple machines and types for business and access through the cloud, as we all have come to know where the Internet of Things resides. Big data analytics, this is a really big part of also evolving computer science into being able to take all that data, imagine all the data that's out there, and analyze it in a good way. And I'll have some examples of that later on in this overview. Again, it's the circulation, collection, and analysis of the information to really make smart decisions from and help the machines get smarter again and more preventative in their maintenance. Artificial intelligence, we have heard a lot about that, and it continues to grow. Multiple applications in machines and robots where they can be fitted with chips and be able to understand a lot of things are sensors that are tied to vibration or heat, and those then send those information bits back to the computer, and the analytics are sometimes deciphered by artificial intelligence. So the Internet of Things connects with the AI system to the cloud, and it's very useful for workers when they're performing and refining these data analytics and communications back and forth to these machines. So that's a big part of the future as well. Augmented virtual extended reality I talked about. This is being able to get involved with troubleshooting of a machine using a headset or a computer virtually, and being able to actually make adjustments to that with digital controls or even your hand movement in the cloud. And that is continuing to evolve. It's also a lot of game players use virtual reality to be immersed in the gameplay. And it's nothing different. It's just a different application when it's used to maintain equipment in the factory. Systems integration, again, this goes all across all the computer integrated manufacturing that's already been there, all the way through ERP systems that drive companies and do their business and purchasing and supply chain. It's everywhere. So the Industry 4.0 touches all these systems and integrates more seamlessly than ever before across all departments, functions, and capabilities, making things much more smart, as we talked about, smart manufacturing. Simulation and digital twins, really synonymous again, where you can generate a digital version of what's going on and actually simulate some things through that process, so you don't crash a machine or make a mistake with a process. You can do it virtually in the simulation and then correct things before they actually hit the real factory floor. And this is really continuing on in model-based systems engineering, very important for a lot of students who are in the field of engineering or computer science to come together and understand how they can work together in these simulations and digital twins. Cybersecurity, as I mentioned, is one of the biggest areas that's growing rapidly every day. It is protecting those communications protocols and the data that's out there from being cyber attacked by criminals across the globe. As I speak to you, we've had many cyber attacks in everything from department store sites to infrastructure sites in the United States and across the globe that need to be continually improved and perfected so that we don't have vulnerabilities out there and sabotage of data leaks, et cetera. So those things, if you can get into cybersecurity and that's an interest, you'll probably always have a job in the future. So Industry 4.0 plus industrial Internet of Things, basically, if you put those two together, you've got all that working in a globally competitive world for manufacturing. Some of the feedback we gathered from educators is that entry-level jobs are changing at a rapid pace. Obviously, the curriculum needs to quickly change, more quickly than it's ever changed in colleges and even K through 12. Those interrelatednesses of advanced manufacturing disciplines continue to merge. A lot of our colleges and schools are taking information technology, engineering technology, and manufacturing technology and merging them into one mega department because they're all interconnected and they should be taught that way. The effects on artificial intelligence and human interfaces is really across all disciplines. It's cross-disciplinary, and you need to continually understand how they're connected and identify and update appropriately. So you'll never stop learning with Industry 4.0. There's always something new every day. You know, a lot of the folks basically said we need to integrate instructor training and professional development ongoing with new equipment in the labs, making sure that industry and employers are involved in that, and quickly upgrade and improve the curriculum development so that we're always keeping ahead of the curve. That's tough to do sometimes. But the main way to do that is keep the employers truly engaged. And that's a big part of this career summit is employers are coming together with students and educators, making sure that we're all talking the same language and helping each other with those future jobs, the current day jobs, as well as career exploration for the future. Obviously, Industry 4.0 continues to evolve, and we have to continually look at those gaps in the curriculum and the programs at the college, and using stackable credentials and emerging certifications, which we'll talk about for upskilling, reskilling, and actually lifelong learning. If you can think about the term K to gray, kindergarten to my gray hair, it's always a learning experience, and important for you to always think you can never stop learning, because that's what the world's all about. Once you do, you'll be left behind. And so it's important to keep that in mind, lifelong learning. So really the components of this is, you look at a shop floor with the internet connected, there's all kinds of components, interfaces, and standards in these factory networks. There's a lot of algorithms, which, you know, if you do anything on Amazon or any of those systems that you search for a certain product or service, it knows what you're looking for and will remind you until you tell it to stop. Those are those algorithms that continually help artificial intelligence be part of the equation. If you look at a connected gateway here with the cloud computing at the far left, with a programmable logic controller in the middle, connected to whether it's a motor or a robot or a CNC machine at the top of the screen, all the way over to a vision quality control machine, and all the way out to the supply chain, shipping, and logistics. It's all wired or wireless, depending on the situation, and connected by the Internet of Things in the shop floor. This is really a quick depiction of what the modern factory looks like today. So you all know career exploration in manufacturing is definitely state of the art and important for you to know. It's clean, it's safe, and it's really high tech. Questions on business, we won't go into this much, but we're always looking at business and industry to say, what are you looking at in the next 5 to 10 years? What are you thinking about? Technology will change for you. What knowledge and skill sets and competencies are you looking for in future or your current workforce that you don't have? How can you get there? And then what soft skills and employability skills are also important. We'll talk about that in a minute or two as well. And then how is Industry 4.0 impacting your industry right now and in the future? And as we all have learned, the COVID pandemic in the last 15 or 16 months has greatly improved the speed of which a lot of companies have dived into virtual and robotics and all those things we're talking about today. Forbes has said 5.3 times faster than they experienced in the past because of the pandemic. Companies have made those jumps. So you'll be seeing a lot more of Industry 4.0 in factories than you did before the pandemic and going forward. Very important to know. And the challenges facing the companies, we asked, this is the top 5 or 6 bullets. Those challenges are here and now. They're definitely, as I said, exacerbated and sped up by the pandemic. They need to be flexible and agile and have greater access to the talent coming out of the K through 12 and community colleges and colleges. They're really looking for zero downtime, and the Industry 4.0 will help, and I'll explain that a little bit more. And machines are no longer standalone. They're really integrated in global networks, and this will be part of that as we talk about more Industry 4.0 in this overview. All right, what implications do technical education, this is from industries looking at education, what they're looking for. They need to be able to bridge the virtual and live experiences in the workplace. A lot of the students listening to this are gamers, and that is a really big part of the virtual reality and the simulation and all those things that are really part of manufacturing today. If you're a good gamer and you understand that, you will be a great programmer or machine coordinator in Industry 4.0 world. Cybersecurity, as I mentioned, must be taught across the board and embedded at all levels and across the entire enterprise. It's really important to understand the business model with Industry 4.0. IT students, if you're one of those, must understand the digital transformations that are going on everywhere. You just don't do IT for IT's sake, and you haven't for a long time, but it's even more important to understand how it motivates manufacturing in the Industry 4.0 world. These are these essential soft skills, if you will, or workplace skills that in a nutshell, that an industry says they're looking for, so you can be aware of that. Obviously, communications competencies, being able to be clear and respectful and use professional terminology, being a critical listener and provide and receive feedback. Those are some of the highlights of communication that the industry is looking for from students that are evolving into those new jobs. Professional and career management, identify opportunities for professional growth, articulate your personal strengths and be able to identify opportunities when they're presented that you can fit into. Also cultural competence, the ability to analyze the components of your self-awareness, which include your personality values, your habits, the needs and motivations you have, being part of a diverse community as well as being diverse yourself, and demonstrate a respect for a complex range of cultural norms and experiences among diverse population. Those are a real big part of the cultural competence that industry is looking for. And of course, critical thinking and problem solving skills are very much at the top of the food chain too. How do you identify issues and analyze them? How do you evaluate information and use evidence and data to make decisions throughout the process of problem solving and critical thinking? Big part of what industry is looking for, as well as teamwork and collaboration. And how do you assume appropriate roles where you stand in your current position or your new role as a student going into your first time job? Respect for others' viewpoints, contributing to the team efforts, not trying to be a standalone and it's my way or the highway type of person. Build on collaborative relationships and really do listen empathically to others, and resolve conflicts constructively. All of these are very important pieces of that puzzle. And of course, your technology competence, whether it's just basically digital proficiency or adapting to evolving technologies that we're covering here today, identifying innovative applications for technology and using it ethically and responsibly. I mean, that's a huge piece of cybersecurity and artificial intelligence. All of these tools can be used for many things that are good, but a few folks that are bad actors can use them for bad as well. So being ethical and using these tools is very important to our industry, and aligning a technology to the job at hand is really important. And of course, a balance of using technology with other communication channels where appropriate is part of the equation as well. This is a really great list of essential career competencies that you should make sure you remember when you're interviewing for a job, or you're in a job, or any of these situations you find yourself in going forward, to improve and continually be part of the solution, not part of the problem. All right. Now, some of the skill areas were defined into 3 big buckets. And we talked briefly about advanced digital literacy. We talked a little bit about business knowledge and processes. And then last, but certainly not least, skill area is data knowledge and analytics. We're just going to dive into those, what those mean real quick. If you look at the advanced digital literacy, those are the AI software tools that we talked about, the automation and robotics, basic programming, coding. Python's a real high need out there, cloud computing and digital fluency and the vocabulary. Learning all that and what it means is really important for you to get a hold of if you don't already have that. We talked about digital twins and edge computing, which is cloud computing, a different approach. Those human machine interfaces and functional block programming, these are all important aspects of advanced digital literacy from industry's perspective, to educators and to students. Digital machine learning, network architecture, knowing what IP addresses and things like that are, really important to connect all the dots and know that terminology and how they work with network devices and communication, of course, security controls as well. Now, if we look at the next level of skills, we look at business knowledge and processes. A lot of you probably are studying blockchain, business cycles and communications, and continuous process improvement. A lot of folks that know me know that I stand on one premise for sure, is that if it's not broke, we should break it, because there's always a better way of doing things. And this is part of continuous process improvement. A lot of folks that are out there as students in the Student Summit may turn into be an entrepreneur. That's a huge undertaking, but it's a really noble one. Entrepreneurs are highly valued, and look at Steve Jobs and Bill Gates, who started Microsoft and Apple. They started in their garages with an idea as an entrepreneur, and look where those companies are 40 years later. You have access to becoming your own boss and being an entrepreneur as well. Customer focus is a huge piece of business knowledge and processes. Lean processes, you'll learn about that if you haven't already in school or in your business job. Look at market trends and where things are that we're talking about today are headed. Plug into those knowledge bases and learn about production and distribution, that supply chain, and risk management, as well as vertical and horizontal integration. These are all parts of what industry looks at as always knowing more about their industry than just what your job role is currently, so you can continue to understand who is upstream and downstream from you, and how what your decisions and actions do make an impact on them directly. Last but certainly not least in the skill areas is number 3, and that is the data, knowledge, and analytics, interpreting and making decisions. So computational thinking, data analytics, understanding the data backup and restoration of data so it doesn't get lost or tainted. How the data is flowing from their origin of it, where it's coming from, to the dashboard or the end user. Being able to be fluent in the vocabulary of what you're talking about with data, and the management and storage of that data, understanding that. Obviously modeling, data modeling on a dashboard or in a spreadsheet, SQL, query language for databases. Statistics is a huge piece of understanding how to use data analytics and process it and make decisions from it. And then obviously virtual or visual representations of data are also very big tools in business that you can learn and use more readily. These are all important parts of the puzzle for data and understanding how to use it in industry. Okay, and cross-sectional regional engagement, adopting to a common nomenclature. That's why we started this presentation with Glossary of Terms. If you understand what those definitions are in a quick, concise way, and you can communicate them to all populations, whether they're people that don't understand at all what you're talking about, and you can draw a picture to your watch or your phone and how it's connected to the internet and how it's connected to apps, then you've got it made, because then you can grow it to that physical, cyber physical connected factory. Obviously, address both the here and now, keep looking at the future of work and how it's evolving, because it is every day. You got to start small, like I mentioned, and address, production and efficiency and security with cybersecurity, always being at the forefront of what you're talking about with this Industry 4.0, and invest in workforce training. Training never ends, as I talked about lifelong learning before. All right. This is just a pictorial of those 8 or 9 key pillars of Industry 4.0 around robotics and simulation and additive manufacturing and cybersecurity that I talked about. It's a nice picture of the whole puzzle circulating around what's really going on a daily basis in smart manufacturing. Here's a lab. which is called a mega lab. Here's some kind of the training equipment by one of our partners called by the name of Festo. You'll see some Fanuc Robotics in there, as well as some other controls. Very clean. This is emulating a real shop floor in a factory, but it's a training environment in Tennessee. Another training environment in that space is for cybersecurity. Again, emulating a real world example of that here in this lab for you to get a feel for what they look like. Again, our qualifications for Industry 4.0, we've got several really important people out there in the world working on this. With Tesla, a lot of you know Elon Musk, another hero of ours and mine in SpaceX, and Tesla and many other endeavors, is working with a college in Nevada, Truckee Meadows, with partners like Siemens and NIMS and Festo on credentials that are stackable and portable. And a group that we work very closely with in the National Skills Coalition, the National Coalition of Certification Centers. We do work with the National Skills Coalition, but they all have similar names. But the National Coalition of Certification Centers, commonly known as NC3, is at the forefront of collecting and making sure all of these certifications are, stackable, portable approach for industry and students alike. And that is a big part of Industry 4.0 going forward. Here's a quick overview of skills learning, lifelong learning is at the very top of the food chain. 91% of industry and students believe that lifelong learning is part of the equation of being successful. With interdisciplinary thinking, as we talked about, active problem solving, greater IT competencies or digital competencies that we talked about, ongoing with this chart, self-directed communication skills and individual abilities of potential employees are very important in this chart. But if you look at the NC3 Industry 4.0 certification program, it talks about 3 levels. In this case, level 1 is fundamentals with those 5 or 6 disciplines that we talked about early on: electrical, fluid power, mechanical, PLC, robotics, and Industry 4.0 fundamentals. Then level 2 is your advanced mechatronics. We talked about that briefly, where you have applied fluid power and mechanical systems. Everything's applied in this level once you've learned how they connect in the level 1. And then you get into the level 3, which is the true Industry 4.0, where everything is more connected: the human-machine interface, the smart maintenance, advanced robotics, cybersecurity, etc. This is the level 1, 2, and 3 that NC3 has worked on with those partners I mentioned, and you'll see this in the field as you grow. Again, another version of this with big data, augmented reality, monitoring, cyber physical systems, again, the ERP MES systems, which is the way their business is run, and even radio frequency identification, RFID, is part of the supply chain going forward with the machine-to-machine communication from start to finish. This is another good graphic representation of what Industry 4.0 with additional technology being embedded is all about. Again, this is the same thing I talked about in a different way, represented with more detail in what's involved in each of those levels, 1, 2, and 3, with some of the specifics being looked at in each of those areas. I won't dwell on that, but you can look at that and save it for future use, or pause and take notes. And then we also have another group called the Smart Automation Certification Alliance, run by a fine gentleman by the name of Jim Wall, who came from the NIMS environment. And they've worked on 4 levels of Industry 4.0 certification, from the basic operations to advanced and robotics, and then finally to the industrial Internet of Things. That's called SAKA for short. And that group is laid out in 4 different areas. Those same basic principles and certification areas of competencies listed here, and they're color coded with red, green, blue, and purple, based on those 4 levels. And I won't go into each one of those on this presentation, but you can pause and take notes as well for these. They match very closely the NC3 Festo Siemens approach that we talked about in earlier slides. All right, this is a real world example, and we're ending our presentation with this. This is live at Fanuc Robotics in Michigan, and they have a Internet of Things connection across the globe. You see the globe map there. This is several years old, and they've got well over double this number of robots connected to this Internet of Things now, but they had almost 17,000 a couple of years ago when I visited and took pictures of this screen, and it's called their Zero Downtime Portal. And each one of these robots is connected, and you see Austria with 8 robots monitored at this particular site, and they're connected to be able to look at vibration, heat, etc., things that might make a robot fail. And if you look at the next screen, it's a close-up view of what's going on in this field system that they run. The predictive maintenance that they can actually run on these robots and say, you need to take this robot down and provide a new bearing in this position because it's running hot, or you need more grease, lubricant to make sure it doesn't rub against the wrong areas and overheat, or the vibration, etc. And so all of these are on a dashboard, which you see on this screen, looking at the health of the robots, looking at the maintenance that has been performed already and what's coming up, as well as any yellow or red lights that would say caution or stop, so that you don't crash the system for the robot handling what it's doing in the field. This is a very perfect example of Industry 4.0 with robotics in the real world. All right. And I'll leave you with this slide. This is a couple years old. I'll find a new one someday. But this is just a quick snapshot of all the companies 2 years ago that were involved in Industry 4.0 technology. Everything from the bottom systems integrators to cybersecurity to microchips and sensors and connectivity hardware, the connected industry building blocks at the top, all the way over to supporting technologies with additive manufacturing, augmented and virtual reality, collaborative robots, connected vision machines for quality control, and even drones and unmanned vehicles, aerial vehicles are in this mix, and even self-driving vehicles. You'll see a lot of logos and company names that you recognize, many of those that we've talked about in this presentation that are partners of NCATC. And I'll leave it at that so that you can ask questions. My contact information is here, and I appreciate your time and your interest in Industry 4.0 and what it means for the future of work. And hopefully you attending the Student Summit today and through the next couple days, if you see this presentation and you get something from it, ping me at craig@ncatc.org, or give me a text or a call on our phone at 440-600-7749. I am the CEO and Executive Director of NCATC, and I look forward to hearing good things from the Student Summit, the Career Summit for NTMA in 2021. Thank you so much for your time, and I'll end now. Goodbye for now.